one of the co-chairs of this task force, and the other one is James Sanker sitting there. Okay, I want to, this talk essentially has two parts. One part where I will speak very fast because it's mainly a refresher, and one part where I will actually talk about new things. And in particular, I will try to get you to do some work when you go home. So when we talk about wireless LAN security, we are talking about two things. We're talking about confidentiality. We want to make sure that nobody can listen to the traffic that is exchanged over the air. And we are talking about accountability. And of course, accountability is more to the hearts of the people running these wireless LANs. They want to be able to find out who did the bad things. The Task Force Mobility has been working on this issue for about 18 months. And last year in Zagreb, when I reported about this, I showed this picture which shows two security researchers working on the problem, and you can see it. We still had some work to do, and I can report that we have significant progress, or maybe not. That was on the screen here yesterday evening when we left the room. Okay, so there are two major approaches to getting wireless LAN security. One is where you have the access point as the network boundary. And we all know that the old way of doing this, the wide equivalent privacy, was broken. So we are now all, those who are using this technology are now all using 802.1x as the underlying technology and are slowly shifting to 802.11i as the set of standards for security being in use there. The other approach is to not try to do a Maginot Line style defense of the network, but rather do it somewhere in the network. Let the people in, but they can't do very much before they get to a gateway. And there are two sub-approaches here. One is using VPN gateways, where you have to authenticate before you can open a VPN connection, typically PPTP or IPsec, or sometimes SSH. And the other one is using a web diverter, where you are diverted to a web page where you have to put in your credentials before you get access. Now, the latter technology is security-wise maybe not quite up to par with the other technologies, but it's very convenient. So it's in wide use, in particular in hotspot-style arrangements. So to show this graphically, this is essentially the .1x world. The red part on the left is the insecure. It's not very red on this screen, but the thing with the red lines around it on the left is the insecure world, and the access points actually provide the defense. And the access points use radio servers, typically in all non-trivial deployments, to check the user credentials provided to them. And once you are in the access network, you are green, you are in, you can do whatever you're supposed to do in this access network. And last year I gave a lot of reasons why 802.1x is really what you want. I'm not going to repeat all those, but there are many good reasons why 802.1x is liked very much. Another approach is to use VPN gateways. So you are not defending the network. We are calling the network where people initially attach to the docking network. And you cannot do very many useful things in the docking network. There are a few free services here, like, for instance, help pages telling you how to get on the VPN gateways. But the security is actually provided by the VPN gateways, which have some form of credential checking, which is not of interest here. And as I told last year, there are very many reasons why you want to do this instead of 802.1x. So there are some people who are continuing to do this. This was the method of choice about 4 years ago. So those who were early in this game typically are doing this. And the third approach looks very similar from a high-level point of view. You have this access control device instead of a VPN gateway, and you talk to the access control device by opening www.cnn.com or any other web page, and instead the access control device redirects the web access to some local web server which provides you with a way to put in credentials, and then the access control device punches a hole in its firewall and lets you out to the real world. And there are many good reasons why you want to do this. So the essence is we found that it's not possible to just mandate Europe is going to use one of these three approaches. We are going to continue to see all three approaches, and we need to find ways to make them work. Now, all I said so far was about local access control. So how do we get to roaming? And what is roaming? Well, roaming, in the way we understand it, means that any NRAN user can go to any NRAN institution and use their wireless LAN as if they were at home. That's really the objective, and all this should happen without administrative overhead. And of course, we want usability and we want to maintain security. So how do you do this? 802.1x uses radius backend, so it's not particularly hard to do to this radius backend what people already have done to other radius backends, which is they connect the radio server of a visited institution to some proxy server and then to the radio server of the home institution of the visitor to check the credentials of the visitor. So the visitor actually tells the visited network, I'm of my home institution, and gives the appropriate credentials, and the radio's hierarchy makes it possible to check those credentials. So that's something that people know how to do, because they typically have done this for dial-up already, sometimes on a national scale, sometimes on a smaller scale. So it's relatively easy to make this work. And actually, you can do the same thing with the web-based approach. When you do the credential checking based on radius, again, you can do a radius hierarchy, and that's something that, for instance, was done in Finland. So by just extending the backend and using the radius hierarchy to do the credential checking, it's very easy to extend both web-based and 802.1x-based access. With VPN, that's actually not the method of choice. The method of choice is to actually interconnect the docking networks. So you can get packets from one docking network to the other docking network. And now if this guy here from the institution down here tries to get on the internet, then the connection just goes through the docking networks to the VPN gateway at home. And there the visitor can authenticate, and the packets actually leave the VPN gateway at home, so the visitor has a home identity on the internet all the time. So some things that are attractive. Of course, the fun part is doing this violet thing here, interconnecting the docking networks. There are various federations of this kind at work. There is one in Bremen. There is a much larger one in Switzerland, where essentially all the Wi-Fi universities are interconnected in this way. So just to show you how it looks like in Bremen, we have all the colleges and universities, all the state-owned ones interconnected in this way. So wherever you are in Bremen, you can use your credentials from the other institutions. Okay, all these things work nicely on a statewide scale, on a national scale. How do you actually do this on a European scale? For the radius work, we essentially need to find a European top level, and SURFnet has volunteered to do this. So there is a European top level radius proxy at SURFnet, and we are in the process of connecting more and more country top levels country NREN top levels to this European top level. The red ones are active, and the blue ones are in the process of being connected. Some of these actually have a larger penetration than others. So, for instance, in Croatia, we have almost 200 universities that are part of this radius hierarchy, while other countries like Germany are just starting with, I think, 15 universities in the hierarchy. But this is ongoing work, and it's growing, and we expect a lot more countries to join within the next few months. So that's essentially one focus of the activity of the Task Force Mobility, making this radius hierarchy happen and solve all the pesky little problems that come up when you do something like this on a European scale. Now, how do you do the interconnection of the docking networks? That's, of course, much harder because you are trying to have a separate network structure that is separate from your normal internet. And we wrestled with this problem for a while and then came up with the idea of not really interconnecting the docking networks, but just providing an address space where people can put their VPN gateways. So we make sure that the docking networks can all access this address space, and that's essentially all special plumbing that needs to be done. So what needs to be done is the hosts on the docking network can freely interchange packets with hosts in the controlled address space for gateways, and all the VPN gateways get an additional address in this space, or maybe their main address will be in this space, depending on how an institution actually works. And then it's a small matter of routing to make sure that these addresses actually get delivered. So this, on the top right here, is actually the registration of the German part of this address space. So what happens is that once we have this controlled address space, we can ask the various access controllers in the various networks to let packets through to the controlled address space, and we find some way of routing packets from the controlled address space to the various VPN gateways. So how much address space do we need? I once did a back-of-the-envelope calculation, and my result was we need about one address per 10,000 population. So in Europe, we would need some 40,000 addresses, or Switzerland maybe needs 600, or Bremen needs 60, and so on. We don't have that allocation yet, but we are only starting to put it in. So when you actually put systems into this controlled address space, you are making a pledge. You are saying two things. One, you will gladly accept any packet you get. There is no such thing as a security incident on the controlled address space, because this directly connects to unauthenticated systems in the docking networks. So you should only put systems that are meant for this, VPN gateways and other authenticating systems, into the controlled address space. And the other pledge you make is you don't put useful things in there, because if you put useful things in there, then people who don't authenticate might use them. So you have to resist from putting your university image videos in the controlled address space, because unauthenticated people might download them and cause network traffic that is not authorized. Okay, so the summary of the first part of this talk is we have all the various things in place that we need to do roaming within the technologies at the European level. There is still some rollout to be done, but we have the technologies. Now, how do you integrate all these at the site level? Each of you has a site and wants to make sure that you actually can interoperate with sites that actually may use a different technology as their primary access control technology. If you look at the three technologies, you can see some commonalities. .1x and web both use a radius backend, which makes it pretty easy to integrate them. And web and VPN both use open docking networks. So there are some commonalities, but of course there are also some differences. So when you're going home to your home institution or to your home NREN and start talking to home institutions, the first thing you should consider is, how can I help my users to get service when they go to a different place? How can I help as a home institution? And if you are a radius-based site, then you have to implement the other backend. So if you are a .1x site, you may not have a need for a VPN gateway, but you should have one available, or maybe subscribe to one that your NREN provides for you if the NREN is entirely .1x, so that your users are able to come in when they go to a VPN-only site. And one little thing that has to be remembered is that the radius you provide for web isn't exactly the radius you provide for .1x. For .1x you use things like TTLS, and for the web access you possibly use simpler forms of radius access. So you have to look at your radius server whether they actually interoperate with all the web-based gateways out there. Of course, if you are a VPN site, then the main thing you need to do is run a radius server and possibly integrate that with your access control infrastructure. And one thing you also can do is help your users to set up their roaming configuration while they are still at home, because it's much easier to help them while they are at home. So that's one big incentive to actually play visited site. But you want to play visited site anyway, because you have important guests coming in to your institution from other institutions. So you should implement the other front ends. And well, if you are a docking network site, it's pretty easy to implement the other docking approach. So if you're a web-based site, opening access to the cask space is like 12 lines of iOS configuration. Or if you are a cask site, then you can put in a Linux box with no cat and use this as a simple web diverter. For the .1x based visitors, you want to implement a separate SSID, assuming that your hardware can do that. I'll get back to that in a minute. And deploy this in addition to the OpenSSID that you already have. So people who come in and have laptops configured to use the EduRoam SSID will simply access it and not even notice that they are roaming. Well, if you are a .1x site, then of course the only thing you need to do is implementing an open SSID and do the 6 lines for cask access and put in a web diverter. But you want to have a web diverter anyway, because if you want to provide any conference access, it's way too complicated to have conference users use .1x in all cases. So you want to have a web diverter in your system anyway. By the way, once you do this, you will find out that your local users will like having that flexibility. So if you are a VPN-only site, you might find that Windows XP users actually like .1x because it makes their life simpler. Or if you are a site that has strong security deployed everywhere, you might find users that prefer the simple web access. Okay, so that's maybe something that you have to keep under control using some policy or maybe some little hurdles that make things a little bit more complicated for local users, but it's not hard to provide good access for visitors. So how do you do this multiple SSID game? If you have a certain kind of access point, like the Cisco 1200, then you can simply configure multiple SSIDs on the single access point, assign these SSIDs to different virtual LANs, and then take everything apart again in the switches you use to build your docking network. So essentially, you open another SSID, use a separate virtual LAN, and implement the other front-end technology there. Now, some of us, of course, don't have this kind of hardware. And in this case, there is, apart from throwing out everything you have and buying new hardware, there is little other you can do than putting in additional access points, which may be something you want to do for auditoriums where you expect large numbers of guests and things like that. So you can support visiting users with maybe 5% of your existing effort. So how do you actually make all of this work? I'm going to show you a few lines of iOS CLI just to show it's really not hard. If you want to put in something like a controlled address space for gateways or an access control device, you essentially need these two lines of configuration in the router that keeps together your docking network. Now, if your docking network is entirely layer 2, you may have to put in a router. We actually put in a Cisco 7000 for our system. That was good enough, and it's something like 200 euros on eBay. The router that does the controlled address space for gateway interconnection essentially needs an access list. So it's also something that's relatively simple to configure. Of course, this access list, the blue parts here on the screen, actually do change when other countries make national allocations for the CASC. So I expect to hear about a national allocation for Switzerland soon, and then you would have additional copies of the lines with the blue numbers in them. And finally, if your docking net currently is an RFC 1918 net, a non-public net, then you have to set up some netting. And you don't want to do port-based netting because VPN protocols don't work through port-based netting in general. So what we have done is we have put in some host-based netting, and this is actually 5 lines of iOS CLI. This allows those hosts within the docking network that need to access the controlled address space to have outward-facing addresses from an address space that we reserved for this. And this is essentially all you need to do. Okay, so where are we with all this? Looking at our deployment in Bremen, we still have a few fun little issues. For instance, our Cisco 340 access points can do everything that I talked about, except that 1/3 of them can't. There is some hardware issue with them. We bought all of them at the same time, but 1/3 of them has older hardware and cannot do virtual LANs. We are also seeing some interesting issues, in particular with Linux drivers, but also with Windows 0 configuration when you have multiple SSIDs. So you probably still want to make sure that the default SSID that is announced on your network is the one that you are using for the majority of your supported users. And there are also other little issues like which IP addresses do you give to the roaming users? In the VPN approach, you never need to worry about that because everybody who comes in uses an IP address of their home institution. But if you have visitors using the web-based or the .1x-based approach, you have to give them IP addresses. And if your infrastructure essentially uses IP address ranges for authentication, you have to think about that. And on the other hand, your address space pool you use for this must be big enough for the next big conference you are planning. So when you are expecting to have a 2,000 visitor conference at your university, expect 2/3 of those to have laptops. So you cannot get by with a /24. You need lots of address space for this. One other unnicety is that the CASC space is currently being allocated on a national level, so this is changing, so you have to update the blue things on the previous slides I just had. But I think this slide is pretty much all the issues that we had when we deployed this in Bremen. So the conclusion from this talk that you should take home is it is possible to create a fully interoperable solution. It does require work at the individual sites, but it's not that hard. And we actually have written a little cookbook, which is the deliverable H of the task force mobility, that should help you in getting the work done. The task force mobility is requesting Terreno to have a second term, so we will continue to look at this, continue to evolve our cookbooks and recommendations, and maybe also invent new things in the course. But I think we now have a set of solutions that actually works and can be rolled out. And again, the fun thing is you will notice your users are going to like having the flexibility, and your admins will like having an easy upgrade path from whatever is deployed in your system today to whatever you may want to deploy in the future. So, in summary, go for it. Make it work in your home institution.
Thank you very much, Karsten, for this comprehensive overview of the work of the TF Mobility. We have room for just one or two questions. Are there any questions? I guess it was perfectly clear then. Once again, thank you, Karsten. Our next speaker is Carlos Ribeiro. He is professor of computer science and information systems at the Technical University of Lisbon. Carlos is going to present another way of getting around this problem of getting to your home VPN concentrator. In fact, he doesn't connect to it at all. He has created a solution where you connect to the VPN concentrator at the location you are visiting. And to make this into a secure solution, he has combined that with a PKI approach. But let me not try to give his talk and give the floor to Carlos.
Okay, thank you, Klaas. That's really it. What I'm going to describe is just one solution that we have deployed in our campus. We have another solution and intend to deploy at least one more, but this is the solution we prefer. Let's start from the beginning. When we have started this project, our primary goal was to provide user authentication, data encryption, and automatic roaming on Wi-Fi networks. This was our primary goal. The automatic roaming requirement resulted from our participation in the EU initiative, which is a Portuguese government initiative which aimed to provide wireless networks in universities with a common authentication infrastructure. So this was not really in the beginning, but was this requirement came pretty much when we were studying the thing. Also, we wanted our solution to be deliverable on most computers and Wi-Fi access points. Well, we have at that time already several access points with limited capacities, and we wanted our solution to be deliverable also on that Wi-Fi access points and on most computers, of course. We also wanted our solution to be simple to deploy. In particular, we also wanted our solution to be incrementable deployable. This was important because we wanted that every institution runs at its own pace. No one has to wait for no one else. We wanted, and this is particularly important, that our solution would be simple to use by clients. We know that everything is 3 clicks away. It's too difficult for most clients. Therefore, we studied this very much. And finally, we wanted that our solution be scalable to many users and to several institutions, to many institutions. Well, given these requirements, we have chosen to go to IPsec VPNs with client certificates. Why IPsec VPNs with client certificates? Let's start by why VPNs. Well, VPNs provide encryption and both data and peer authentication. So it was a good start. And why IPsec? Well, IPsec is a well-tested standard and is present in both IPv4 and IPv6, so it was a good thing to do. But why client certificates? Well, simply because they simplify roaming. You see, with a proper configured authentication server, it is possible to authenticate any client with a certificate issued by another institution locally by that authentication server. I will get back to this later. Well, how have we deployed this? The architecture is, in fact, very simple. Here we have a schematic of an hotspot, where here the internal network is just the campus internal network with the several subnets and probably firewalls and so on. And here we have an external firewall you can have or you can not. The thing is important is this internal firewall here, which is also a VPN gateway. This firewall connects this VLAN where all access points are connected with the campus internal network and with the internet. This firewall blocks almost every unauthenticated traffic from the VLAN to the internal network, to the campus internal network and to the internet. Almost because HTTP and HTTPS traffic are not blocked. They are redirected to a special HTTPS server. The purpose of this HTTPS server is twofold. The first one is to provide new users with a welcoming screen and some help instructions. The second one is to provide credentials to users. These credentials are provided through an HTTPS channel, authenticated HTTPS channel, and are stored in some sort of directory server. After having these credentials, every user is able to establish a VPN with the VPN gateway. The traffic carried by this VPN is allowed through the firewall into the campus internal network and the internet. However, the actually accessible subnetworks depend on the certificate of the user. If, for instance, if the user is a local user, he can have access to both the internal campus network and to the internet. But if he's a roaming user, maybe the policy says he only has access to the internet. We can do several things with the properties of the certificate. So, if client certificates are so good, why they are avoided? Well, we all know this answer. Because PKIs are difficult to deploy. In our case, we avoid to deploy a full-feature PKI. What we did was to deploy a simple HTTPS server and a directory server. But to do that, we have to remove some properties from our certificates. Our certificates cannot be used for irrevocable identification. We cannot sign documents and use the private key of these certificates. You cannot use to sign documents. And our certificates have short, medium validity periods. And these were the restrictions we had to make to our certificates. Instead of a PKI, as I said, we deployed an HTTPS server together with a directory server, which in our case was already in place to provide webmail. So it was fairly simple to deploy this infrastructure. The directory server contains the credentials, the client credentials of the local client credentials. By credentials, I mean not only the certificate of each user, but also the private key of each user, and several other certificates which are necessary to build certificate chains. This is an important and different way to go, because by keeping the private keys inside the directory server, we are simplifying both the distribution of the certificates, the credentials, and the management of those credentials. Because by keeping those private keys inside the directory server, supplicants do not need to generate the private keys themselves and go through a certification process. So we simplify distribution, and more important, we simplify management, because you can give those credentials over and over to the same user without having to revoke older ones, because there are no older ones, we are supplying the same ones. And this combined with the fact that our certificates have short validity periods give us the ability to live without certificate revocation lists, which are a pain. Well, until now I have not talked about roaming. I said it was easy, but I didn't talk much about it. The key aspect of this solution concerning to roaming is that each entity is a certification entity for its users. Each entity, each institution has a private key and the self-signed certificate which it uses to generate credentials, certificates for its users. There is no need for a central certification entity that starts the whole process. Each entity and each institution can start generate certificates and give to their local users. In fact, roaming agreements can be put in place incrementally without modifying or reusing local certificates. Certificates issued before the roaming agreements being in place become automatic roaming certificates. There is no need to do anything else. Well, to understand how this is done, let's go briefly how to authenticate someone locally in IPsec with client certificates. First, the supplicant sends his certificate to the gateway, to the VPN gateway, and the VPN gateway verifies the signature on the certificate using the self-signed certificate, the root certificate of its institution, which is the same institution of the supplicant in this local authentication process. It extracts the public key, and the supplicant does the same with the gateway certificate. After having both the public key of each other, they are able to generate a session key and start speaking privately. Well, With the roaming authentication, it's the same thing. Only the verification phase is different. The verification phase is almost identical for bilateral agreements and for multilateral agreements, but the entities involved are slightly different. So let's start with bilateral agreements. In a bilateral agreement, institution A and institution B generate two certificates. And those two certificates need to be on the certificate store of the supplicant and the gateway. Where it is? The gateway has another certificate besides its own self-signed certificate. It has another certificate for institution A signed by its own institution. With this certificate, it is easy to do a certification chain and verify the supplicant certificate. So this is done locally at the authentication gateway, at the VPN gateway. And of course, the supplicant also needs to authenticate the VPN gateway, and he needs a certificate for the signed by its institution for the institution of the gateway. In a multilateral agreement, instead of having each institution doing bilateral agreements with everyone else, we have a trusted entity which does bilateral agreements with every institution. And every institution trusts the bilateral agreements done by that trusted entity. So instead of having one certificate for each bilateral agreement, we need two certificates on each store. One for the bilateral agreement between the supplicant institution, and one between the supplicant institution and the trusted entity, and one for the bilateral agreement between the trusted entity and the gateway institution. But the thing is very simple. After having those things in place, we can simply build a certificate chain and verify locally the supplicant certificate. Of course, we can have a hierarchy of multilateral agreements. We can have a multilateral agreement built on top of another multilateral agreement. For instance, having a national entity, a national trusted entity, which does bilateral agreements with every institution, and then an international trusted entity that does bilateral agreements with every trusted entity. So we have an hierarchy of multilateral agreements, or we can have bilateral agreements between trusted entities and have a mix of multilateral and bilateral agreements. This is fairly easy and very flexible. We don't need to have a fixed structure on everything. But the important thing of this solution is that the root of every chain is always the local root. We do not have to trust a certificate inside our browser or something like that. The root certificate is always the local certificate, here and here. Well, let me say an additional features of this solution, which were not planned in the beginning, but that resulted very nicely. We do not expect that every visitor have a roaming agreement with us. So we need to provide temporary certificates to that users. Instead of having the system administration of our campus to build accounts for everyone, we provided a web page where people that invite usually professors invite colleagues to campus, can generate themselves temporary certificates, 1 day 24-hour certificates or 48-hour certificates. This resulted very nicely because the management is distributed by the professors. They generate the certificates for their visitors, and the certificates expire by themselves. System administration do not need to create accounts and do not need to remove accounts. Everything is transparent. Another interesting feature of our solution is the transparency of authentication. We believe that whenever possible, the wireless connectivity should be transparent. The user should not be asked to do anything, even to insert a username and password. In our solution, that's what happened. We just open a browser and start navigating. The authentication is done transparently by the certificates inside our certificate store. And this is especially good for situations where we have poor connectivity, intermittent connectivity, and we need to be doing authentication every time. And because authentication is done transparently, the only thing the user feels is a slight delay on the browser or on the mail. Well, in conclusion, IPsec is a mature standard which ensures stability and longevity for this solution. We think this solution is ubiquitous because it does not need any special feature from APs, and because we only use mandatory features of IPsec, we have maximum compatibility between IPsec stacks. We now have Windows 2000, Windows XP, Linux, and Mac OS X in place, everything with different IPsec stacks talking with each other. And the roaming infrastructure is extremely light. In fact, we don't need any more infrastructure for roaming than we need for local authentication. The solution does not need a full-feature PKI. We just need an HTTPS server and a directory server to store the certificates. And finally, the authentication process is transparent and offers a simple method to allow limited time to have access to foreign visitors. And the current implementation is completely free. We use open source or, in some cases, native IPsec stacks. We use the native IPsec of Windows XP and Windows 2000, and native IPsec of Mac OS, and open source IPsec in Linux. Therefore, it's almost everything open. And that's it. Thank you.
Thank you, Carlos, for this very interesting presentation. I'm sure there are some questions. If not, I have a couple, but let me first hand to the hall.
Hi, Andrew Cormack from Wierenga. Can you clarify, I think from what you said, if I want to go and visit another site, I have to visit my own site first to download the certificate.
Those certificates are downloaded automatically when you download the credentials.
Yeah, but I have to do that at home beforehand. Yeah, okay. So the certificates can't be very short lifetime because... right. Mm-hmm. Yeah.
We are giving the certificates. We believe that between a week and
yeah, because I'm away from home for a fortnight at the moment, so a 1-week certificate will expire. Okay, yeah. Yeah. Yeah.
That's it. Because the private key you already have.
Yeah.
You only need a new certificate. Therefore, and the certificates are public, therefore you can verify it.
Okay, thank you. Same question.
Other questions? Over there.
Eric Marin, Cisco. The question I had is, apart from CRL management that you described as painful, what would prevent you from using a full-featured PKI? Because from what I've seen, you want to avoid CRL management. Is there anything else?
Yes, I wanted to avoid also the pain of getting users to generate their own, teaching users to generate their own private keys and go to our center to certify and generate a certificate for that private key they generate. I don't want that. I want the simple thing to users, because 2 clicks, 3 clicks the most. Just download they know.
Anyone else? Karsten?
Hello, Karsten.
Yeah, Carsten Morman again. I really like your solution, but the CS type in me cannot help noticing that you are mixing up authentication and authorization here. I mean, you're essentially using an authentication scheme to provide authorization. I mean, this is not unheard of. There are a lot of tokens out there that are...
And more mixers than that.
Did you experience any practical problems from this?
Not at the moment.
You never wished you could turn off a user in mid-span of his
turn off a user,
lifetime.
sorry?
Yeah, let's say you have a security incident and...
okay. Well, we use other methods to do that. Just blacklist that and things like that. We have some spammers, and you were talking about spammers and things like that.
Well, I'm talking about any kind of incident.
Okay. You want to revoke these certificates.
Essentially.
And yes, we don't have that, because for having that, we need a certification verification list. And we don't want certification verification list because that's a pain to manage.
Well, I don't want to revoke the certificate because the user still is authentically the person he is, but I want to remove the authorization. That's really why I was taking up the point.
Yes,
but in this
process, it's the same. We can modify the policy. We can modify the policy at the gateway, but that did not change. If the user wants to go to another university with that certificate, it's okay. But we can change the policy at that gateway where the user is using, because I can say that the certificate of this user, he cannot access any network besides the web page. I can do that, but I cannot prevent the user to go to another university with that certificate, with that valid certificate, and enter the network. That's true.
In the back there.
Excuse me, there is nothing in your system to prevent two users to use the same certificate?
Well, it is possible to do that. In fact, we have that in place. But sometimes it's good not to have that. Sometimes in conference and things like that, it is good to have one certificate for everyone. But we can do that. It's easy to do. In fact, in our campus, that's it. if a user wants to use its laptop and PDA at the same time, he cannot. But that's just an option on the gateway.
But this prevent the use of the system as an identification method.
Sorry?
This prevent the use of the system to account what a user do.
Can I?
Yes, of course, of course. Usually users are those certificates. It's for that user. But in some cases, in conference and things like that, it is nice to manage. We lose something. It's never. There are no free lunches. We lose something. Of course, we lose accountability on conferences and things like that. If you give the same certificate for everyone else, But
if I get your certificate, can I use it?
Yes, you can. You can. Of course, if I'm using it at the same time, you can't, and that is easily detected, and you can prevent you from using it.
Any other questions? Well, most of my questions are answered, but I still have a couple left.
Shoot.
Well, the first is actually more a remark. You are now terminating your VPN at the visited institution when you're a roaming user.
Yeah.
Which basically means that if I want to go securely to my own institution,
You need the VPN over VPN.
I will use another IPsec over IPsec,
Yeah.
and you run in lots of troubles. If you're not careful, you have overhead. How do you look upon that?
Yes, I have a slight overhead on that, but I don't think that's a big problem. I can't see that as a big problem. We do that every day.
Okay.
I do that every day. I do a VPN, a standard VPN, to access to have connectivity, and that VPN is completely transparent for me. And on top of that, I do an explicit VPN with the institute where I'm researching, and that second VPN is explicit. I do it explicit. I start it explicit. But the first one is completely transparent. And I have no problem with that.
But I understand somehow it doesn't really feel right. I understand.
To have two VPN, one...
And also because, like the customer was saying, you are sort of mixing authentication and authorization.
Yeah.
All the thing you are mixing in a bit is access to the network and secure transport. You use a VPN to get access to the network, while I would say AWS.
Yes.
But I'm
Yes.
very partial, so don't crush me on this. It's a much
I
better
don't.
way to regulate the access.
Well, I know that I'm mixing that. But till now, that it is not a problem. And in fact, I have seen several solutions that not only mix authentication, authorization, but mix trust and things like that. Therefore, mixing is not bad.
I do really think you make a very nice system, and that's why the last question I have is, I know that in Portugal they also are part of the European hierarchy, they use 802.1x. So my question is...
We are going to provide, we are just...
how many institutions are using this at the moment?
Just ours. Well, we have another one which asked for informations about it, but we don't know if they have deployed the
But do you think the solution is scalable? If you have 100 institutions, you say multiple, multiple relationships, so you have to collect all the certificates, install all the certificate there.
No. The certificate came...
In your slides, one of the multiple agreements,
Multilateral agreement.
Can you be very short about that?
Sorry.
I can ask also if we
Offline?
Let's do it offline, because we are now taking time of the last speaker. By the way, don't leave the room beforehand. I was assured that there will be today enough lunch for everybody. Thank you again, Carlos. Can I have another round of applause for him?
Thank you. I'm not opening it because I don't know who is.
Yeah, I wanted to say something. Our last speaker for today, he briefly introduced himself already when asking a question, Eric Marais. He works for Cisco as a senior consulting engineer, and he is involved in designing secure networks, both wired and wireless. And given the fact that I think the majority of the access points that are used within the NRANs are Cisco ones, I think this is a really nice opportunity to hear Cisco's vision about where it should go with wireless networking, especially the term identity-based networking that they coined. I really like a lot, so I think it's very interesting to hear about this. Eric.
Thanks. So, working for Cisco, I've been working for the past 3 years on wireless LAN security quite a lot, but I will not talk about wireless LAN here. What I wanted to talk about is, although I will talk a lot about 802.1x as a technology, which is heavily used obviously in wireless LAN, it's been mentioned several times, I'd like to give a practical description of how 802.1x can be used as well in a wired environment, so mostly in switches. And because .1x is very well known because it's been originally adopted a lot in the wireless LAN world, but even more is .1x adopted in switches and even routers later down the road. So I thought it would be also and it still does provide some form of mobility for user when it moves from one campus to another, from one subnet to another. Every time it will connect himself to the network, it will get different type of services associated to its identity. So this is what we call identity-based networking at Cisco, and it's valid for wireless LAN as well as wired. So very briefly, because I understand .1x is a very known technology, so very quickly as a refresher, what we are talking here about is really a port-based network authentication. So upon a successful user authentication, a user will get service granted to him. So service could mean a lot of things, as we will see in a switch environment. And really, it's funny you mentioned this mix of authentication and authorization, and I'll come to that later also with IPsec. But really, we are authenticating someone using .1x, and then the important or the nice added value of .1x is the authorization part, in my view, where because we are using a radius server, we can, based upon a successful authentication, provide flexibility and services around that authentication. And this is what we are talking about here. We have a PC, we have a switch. It could be, again, an access point, but a switch, and a AAA server. We do authentication, and I'll talk about the different authentication mechanisms we can have. But to me, the real important part is this policy instruction or authorization piece, which comes after the authentication. We download from a AAA server, so usually it's a radius server. We can download different things, which I will describe in a minute. And then we have communication, a load for that particular user and for this particular user's MAC address. So the protocol and mechanisms, again, very, very briefly, because I'm pretty sure everyone is, it looks like everyone is already familiar with .1x in the audience. But I'm just putting that slide because usually .1x is thought to come from the wireless world, and it's not. It's been adopted, as I said earlier, a lot by the wireless LAN stuff. And what it does is basically does transport authentication or higher level authentication protocols, such as, and mostly EAP, the Extensible Authentication Protocol. Few terminology, the client is a supplicant, so the client could be a PC, but it could be also, and this is something which will come a lot later down the road at Cisco, but I guess at many other vendors too, where the .1x supplicant not only could be a PC, as I said, but could be a networking device. So it could be a router or a switch authenticating itself to another networking gear. To a POP, for example, in Metro Ethernet, we have this notion of a device authenticating itself through the infrastructure. The authenticator is the network access device, where access point, a switch, and the AAA server is the authentication server. Now, the important piece when it comes to authenticating someone is the EAP type which is used within that tunnel. And there are a full list here of EAP types which are used in .1x. I have put in one slide the ones that you see in wireless LAN, such as, well, everyone are actually for both except LIP, which is a Cisco proprietary mechanism for wireless LAN. But these are the different types you can use. What I can just say from as a feedback, having worked for almost 2 years now on .1x in campus on switches with many customers in Europe, the ones that are mostly used here are protected EAP. The reason is because it comes natively with Windows, so that's basically why it's the type which is used in majority. Now, EAP TLS we did a kind of small survey within Cisco towards our customers, and it looks like about 10-15% are using EAP TLS, so I tend to agree with you, although I do like PKI a lot from a security perspective. The reality is that still a small percentage are using PKI, despite all the things you gain from it. But so 10-15% is not a lot. PIP and EAP TLS are definitely the ones that are used. And you can use EAP GTC, for example, if you want to use also one-time password mechanism when accessing your infrastructure. So I wanted to talk about two things. Again, from a practical perspective, I wanted to talk about two things. This policy instruction that I mentioned earlier, so the authorization part, which does make .1x very useful in my view. And then I wanted to insist a bit more on issues we faced, or most our customers faced, when deploying .1x over the course of the last 2 years. This is being solved right now, but why Microsoft? Because reality is that 90% of the customers' PCs we are working with are Microsoft environment. Although .1x is already available in all other operating systems I'm aware of. So there are different things you can do once a user is authenticated. And again, the things I'm going to describe are, I would say, available in all Cisco equipment, but I want to stay neutral here. And I would tend to say that all the things I'm going to describe are pretty generic now. So I would expect every switch vendors to support some of it, or if not all of it, right? So the first one is dynamic VLAN assignment, and this is like used in every places I've seen, where based upon a successful authentication on a switch, we will put that user on a specific VLAN, exactly like we do it in wireless LAN, based on an SSID, for example, as it's been described earlier. And this is very, very easily done. On the AAA, on the Radius server, we use 3 standards IETF attributes, which are 64, 65, and 81. And in 81, that's where you will define either the VLAN ID itself. So this guy is Eric Marin, put it in VLAN 20, or it could be a VLAN name. And VLAN name is, this name will then map to a specific ID depending on the switch you're coming from. So if I'm connected to a switch in Greece, VLAN name Terena might map to VLAN ID 10. If I'm in France, it could be VLAN 30. So using the VLAN name is actually more powerful in that perspective. But it is very, very easy to do, and this is simply, I'm not even sure you can see it because I don't see it from here, so from the back it's probably even worse. It was supposed to be a screenshot of the Cisco ACS Radius server, but I've been using it with 3 Radius works as well. 3 standard attributes. Guest access as well is one thing which is pretty nice to use for visitors. Guests, visitors, whatever. The switch will actually try to contact this newly connected PC on a port for 3 times, or whatever you configure, but for 3 times. If this PC does not have a supplicant, a .1x supplicant, then we'll put that PC in a guest VLAN. So it's pretty easy. Today on the Cisco switches, this used to be global to the switch. If you enable that feature, that would be for all .1x ports. Now we do that per port. .1x with voice VLAN. I don't know if you're yourself using yet or plan to use one day voice over IP. But the issue we have here is you can find yourself in this situation where you have an IP phone connected to a port, and behind on every Cisco IP phone you have also an RG45 on which is a data port on which you can connect a PC. And this basically saves you on the number of switch ports that you are using. And in that case, what does happen if we have then a .1x supplicant on the PC, which sits behind the IP phone? So we used to have some issues about 2 years or 18 months ago, and now this is being solved, where the switch does recognize using CDP that we have an IP phone connected to that port, and will simply authenticate the data traffic coming from that specific PC behind it. So in that specific configuration, the .1x PC will be authenticated, and the voice traffic will simply pass unauthenticated and untouched through that port. ACL download, also very important, as important or as heavily used as VLAN assignment. Same thing, based on a successful user authentication, we can download on the fly specific per user ACL. So, for example, if this user is coming from that specific group, then he can only go to this specific subnet or to this web server or this whatever. A per user dynamic ACL based upon a .1x successful authentication. And what is actually just coming, and I would say this probably is more Cisco specific, but just to give you a perspective on how flexible the whole .1x story is. And this has mostly been requested by our customers a lot. Quality of service, which is somehow just a different type of ACL on a switch or router. Now we will be able to make smarter decisions based upon a .1x authentication. Now we can say this user does belong to this group. we will put it on that VLAN, and also for FTP, we will limit its traffic to 2 meg or whatever, or guarantee some specific QoS parameters. Accounting, this was a bit of a shame. This was not yet supported on our switches. This is now will be available for .1x users, so we can have some accounting measures. And port naming, which is more a cosmetic feature that I won't describe here. I know you have lunch right after this session, so I'll try to keep it short. Now, I just wanted, based on experiences, I would say, I wanted to put few slides on issues or things if you have not gone through those things yet, things I think you should maybe be aware of. Let's put it that way, which are things we encountered or our customers encountered when deploying .1x with our switches and in a Microsoft environment. Maybe you know that already, so then this is just something which is not .1x related, but I thought would be useful as a background information. When you boot a Windows PC, well, I'm sure you know that anyway, but you load the NDIS driver, then you have the HTTP, and then you establish a secured connection or a secured channel to your domain controller. You do that because, you do that if you need scripts being executed, group policy objects being applied to your machine. And this secured channel to the domain controller is done using some credentials which are being generated when you register to the domain. But then we have the issue if now we are talking about .1x, because .1x is a layer 2 technology, so it will even take place before you even get a DHCP address on your PC, right? So if you do .1x, you usually have to authenticate yourself. If you do .1x and you don't authenticate the PC, then everything else breaks, and mostly scripts and GPUs. So basically, what we're talking here about is machine authentication, where, and I put it in red below here, where the machine will have to authenticate itself as a machine, not as a user, but using its own machine identity. Because let me go one slide back. This only when we are prompted with the Control-Alt-Del GINA DLL, this is where we can finally talk about user authentication. So that's where we finally put our credentials as a user. So here we are talking about two different types of authentication. Machine authentication, where the machine authenticates itself and then can go to the domain controller, and finally user authentication. So we really need to take care of machine authentication when in a Microsoft environment. Well, and the issue comes from the fact that the way you do control machine with user or without user or only machine authentication on a Windows machine is through manual editing of registries. The last I heard is this should be addressed in the next service pack for Windows XP, but this has been a bit of a problem in some deployment where you cannot afford to modify registries for hundreds of machines. I'm not going too much into the details because of time constraint. If you have more questions, I'd be happy to answer by email, emarin@cisco.com. And then the second issue is the DHCP issue. On a machine, on a Microsoft machine, the DHCP starts when once your interface is up. But in some cases, if you but DHCP will eventually time out around after a minute or so. So if you have .1x now, and you're having a cup of coffee somewhere, or you're talking to someone, and it takes more than a minute for you to fill in your username and password, then DHCP will eventually time out. So this is one issue. The second issue is what happens if you are assigned to a default VLAN. You do a first .1x authentication. You're being put in a VLAN because we do VLAN assignments, and you're being put in a different VLAN. Hence, you should also have, or you should be moved to a different subnet, getting a new IP address, for example. This also was an issue with the Microsoft .1x implementation, because DHCP was not restarted in that event. So this is basically a nice slide to tell the same thing. But mostly the issue is what happens if DHCP times out or does not restart based upon a VLAN assignment. So we've been working with Microsoft quite a lot because, and I have nothing against Microsoft, but their primary design goal for .1x on Windows was mostly for wireless LAN. And they haven't done much in identifying issues for .1x in a wired environment. And that's where we've been trying to work with them to give those feedback to them. So this is being solved by Microsoft. And the way this is being done is when we do, for example, VLAN assignment from the authentication server, and we put that user into a different VLAN. Now what the .1x, the Windows supplicant will do, it will restart DHCP when receiving an EAP success frame. Now, we don't simply do that right away because maybe we are put in the same VLAN or our IP address has not changed. First, Microsoft will send 3 pings to the default gateway of the previously assigned IP address. So then we are making sure that we haven't roamed to a different subnet, for example. If we do realize that the old gateway is not reachable, then DHCP is restarted, and then we get a new IP address. So this is addressed, and this issue has been probably the biggest one when working with customers deploying .1x in a wired environment, not in a wireless environment. So in conclusion, I would say that, and I've heard a lot of positive words about how we should use .1x several times this morning. So the good thing is that my conclusion is the same. And my point is that the situation from vendors, from the implementation perspective gets better and better. Most, if not all, operating systems are now supporting or do have a .1x supplicant, macOS, Solaris, Linux, Windows, we just mentioned it. The authorization part, because we're using Radius in most cases, is exactly what gives identity-based networking this great flexibility and extensibility. And it's being deployed more and more, not only on access point, but on switches. And I also wanted to mention, because also to close the loop with the previous session, is that it's also already available, .1x, on iOS in the T-Train. And the way we are using it is we combine it with access to an IPsec VPN tunnels. So what this feature is really about is you're sitting behind a router, a branch router somewhere in your office remotely, and you have an IPsec VPN tunnel established between this remote branch and your university or central IPsec termination point. What we do at this remote branch is we will do .1x. We will authenticate the user using .1x as soon as this user gets connected to a router port. And if this user is successfully authenticated, then is allowed, for example, to get into that IPsec tunnels. If the authentication is not successful, we can simply give him access to the internet using split tunneling, for example. So we used to call that feature internally spouse and kids, or wife and kids, where you're at home, you're behind a router, and well, your kids probably are not supposed to go onto in our case, it was an internal test in the Cisco network, right? So that's why we started deploying that feature. So my point here, .1x will be deployed in more and more networking gears, and I think it's a good thing. And I'm done. And have a good lunch, unless you have questions.
Does anyone have any burning questions before lunch? I suppose the question is already the answer. Just one more remark. You mentioned that PEEP and TLS were mainly used. Especially the early adopters in our community have pretty much chosen all TTLS because there was still the Microsoft Cisco debate about PEEP. And if you plan to use that, at SURFnet we had developed a freely available client called Secure W2. So if you want to use TTLS, have a look at that. Thank you. I hope to see you all back after the lunch for the second mobility session.